In this lecture, we will learn about real and apparent depth. Okay, what is the meaning of this real depth and apparent depth? Suppose you have taken a container, okay, full of water, right? Suppose this is filled with water, and you keep an object at the bottom of the container, right? And you are watching it from outside. What will happen? A ray which comes at the surface here, since this is my denser medium, this is my rarer medium, what will happen? The ray will bend away from the normal, right? This is my what? This is angle I, this is angle R, correct? And one ray will come normal, it will go upswing. So when these two rays meet, my image will be formed here, right? Let us see. This is I, this is O, this is my A, right? So my image is formed here, means anybody who is looking from outside this will see the image of the object here, it will not be here. So this AI is my apparent depth. Okay, it appears that the object is at this place, not at this place, and this AO is my real depth. Okay, we want to calculate the relation between these two. And this OI, what is OI? OI is AO minus AI. This is known as my normal displacement. Okay, you have understood this real depth, apparent depth, and normal displacement. My real depth is AO, my apparent depth is AI, and the difference between these two depths is called as normal displacement. Okay, so applying Snell's law, what we can write here? We can write here is, suppose this is my what? N2, this is my N1. So N2 sine I is equal to N1 sine R, right? Now, since these two lines are parallel to each other, both are normal, right? So we can say this angle R is same corresponding angle here, this angle, and let us name it as, suppose, B, this point. Okay, so what is my sine I? Now if this is I, this is also I, alternate angles, right? So what is sine I? Sine I, we can say AB upon BO, correct? And sine R similarly will be AB upon BI. If you look at this triangle, I am calculating from AOB and R I am calculating from AIB. So sine R is equal to what? AB upon BI, and sine I is equal to AB upon BO, correct? So sine I by sine R will be what? AB will get cancelled. We can write it like BI upon BO, right? And sin I by sin R will be what? It is N1 by N2, right? N1 by N2 means what? Refractive index of N1 with respect to N2, right? Now this at practical, basically, or in normal situation, this point B is very close to A. Okay, we cannot see, our eyes are too small, so this B cannot be very far away. So this B and A will be very close to each other, such that this BI is equivalent to AI. So we can write it as AI, and similarly my BO will be equivalent to AO. So here we have arrived at one formula. So we can say, what is this? 1 is equal to, so, and N1 is what? 1 if it is air, and N2 is the refractive index of glass. So what we can say, sorry, it was 1 to here. We can say 1 upon is equal to AI upon AO, correct? Or by taking reciprocal, we get correct. So what is this? Refractive index of, it's not glass, it is water. If it is filled with water, the refractive index of water with respect to air, of course it is 1, is equal to what? AO is my real depth upon apparent depth. RD and AD are what? Real depth and apparent depth, right? Okay. You can find out your normal displacement also. What is my OY? AO minus AI. If you take AO as outside of common, it will get 1 minus AI by AO. AI by AO is what? 1 upon this. So you can write AO 1 minus 1 upon N2. N2 is what? The refractive index of water. So this is how you can calculate if you know the thickness or you know the depth, the real depth, right? Today we will understand the concept of critical angle and total internal reflection. Okay, we have learned that if a light travels from denser to rarer, suppose this is my denser medium and this is my rarer medium. So if it travels from denser to rarer, it will move away from the normal, correct? This we have already learnt. Now if we keep on increasing the angle I, it will further increase the angle R, right? Understand the process. If I increase the angle, suppose this is my I dash, it will bend away, it will be R dash. So if we keep on increasing the angle of incidence, at one point what will happen? My refracted ray will be at this angle, which is 90 degree, right? So let us draw this again. What I am saying is that I have increased my angle to such an extent, this I, such that my R has become 90 degree. Okay, this angle is known as critical angle for any medium, right? This critical angle for this denser medium, right? So you can define it as the critical angle of any medium is defined as the angle, so that if it is kept along with a rarer medium and the angle of refraction becomes 90 degree, then the angle of incidence is known as critical angle. Okay, in this case, if I apply, suppose this is my n2, this is my n1, if I apply Snell's law, what will happen? n2 sine, now I am writing IC, critical angle as IC, is equal to n1 sine 90. Sine 90 is 1, so we can write sine IC as n1 by n2, or you can write it like this. So your sine IC will be what? 1 upon the refractive index of the denser medium with respect to the rarer medium. You can write like this, right? Or you can write the refractive index of the rarer medium with respect to the denser medium. So you have got a formula for calculating the critical angle, right? Now further, if I increase my angle by little amount, right, suppose my I is greater than IC, what will happen? This R will also increase. Now my refracted ray will not become a refraction, it will be a reflection, right? So this is my new refracted ray, which is actually not a refracted ray, it is a reflected ray, since it is coming back to same medium. So this phenomenon is known as total internal reflection, right? So we can say that whenever my angle of incidence is greater than critical angle, refraction doesn't happen, the whole ray comes back to the same medium, and this process is known as total internal reflection. This is a very important phenomenon, okay, and this time it will follow the law of reflection, okay. So two criteria are there. First, for total internal reflection, first criteria that the ray should move from denser to rarer, means the ray should be moving from denser to rarer side, right? Second, my angle of incidence I should be greater than critical angle. So these are the two criteria so that our total internal reflection takes place, right? This is very important concept. Our optical fibers are based on this concept only, okay? Understood?